my dear student, I'm Mr. Kitwala from Educators. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on the circular motion, uniform circular motion, simple harmonic motion, and also the gravitations. So, my dear student, we will proceed with our subtopic of the gravitations. So on this topic, we are going to continue with one of the part which is called the gravitational field and the field strength. Let us go and see how can we talk what is the meaning of the gravitational field, what is the meaning of the gravitational field strength, how these two things are related is what we are going to see on this discussion here. So when we talk about the gravitational field, this is the region around a body where another massive object will experience a gravitational force of the attractions. Kwamba lile eneo around the massive object, whereby if we take another mass and keep it near, it will experience the gravitational force of attraction. That is what we talk about the gravitational fields, the region around a massive object, whereby another object, when we take it and when we take it and keep near with that mass object, it will experience it will experience a gravitational force of attractions. So the concept of field show that body due to the mass modifies the space around it, that mass of an object. That the region around with that object, it will have it will modify the space around with it. Akasema kwamba such that another object also due to its mass, when brought near to the first object, it will experience the modifications in the form of the force of the gravities. Kwamba imagine we have two objects, my dear students, but the first object is placed at a certain space. If we take another object and keep near with that object, it will experience the force of gravity. It means kwamba we have the force of attraction around with that object which is steady on it is in a stationary or it is at rest. This is why we explain about the concept of the gravitational field and the strength. So, my dear student, the gravitational field strength at a point is therefore defined as the gravitational force experienced by a unit mass of a test at a point M. When we talk about the gravitational field, I think we have tried to see that the thing that we are talking here, we see on this concept, is the relationship between the force and also the mass. So sometimes we say that the gravitational field strength, this is the point. This is also defined as the gravitational force experienced by a unit mass of a test mass at the point. If we want to obtain the gravitational field at a certain point, we must take the gravitational field strength. We must take the gravitational field or the gravitational force, then we divide by the mass. It means the unit mass as we try to see here. So as we see that this is symbol representing the gravitational field strength G, but F will represent the force of the gravity or the gravitational force of attractions. But the mass represents the unit mass, the mass of an object. So if we wanted to take this to obtain this gravitational field strength, we must take the ratio of the force of the gravitational force of gravity then we divide it by the unit mass. It means the mass of an object. But here, if we look about the force of attraction, this occur around with the mass of an object. Where if we take another mass, another object, and keep it near, it will experience that force. So the science of the science in science in which the unit of force is Newton. As we know that always the unit of mass will be equals to 1 Newton, while the science of the mass is in 1 kilogram. This is how we talk about the unit of those ratios. But the unit gravitational field strength is 1 kilogram. It means it will be 1 Newton per unit kilogram, because we obtain the gravitational field strength by taking the force divided by the mass. But the force is in 1 kilogram, and the mass the force is in 1 Newton, while the mass is in 1 kilogram. Therefore, we obtain the unit of the gravitational field strength by taking 1 Newton per 1 kilogram, or Newton per kilogram. That will be the unit. So, my dear student, if we simplify, because inside the Newton, we have a kilogram, we have a meter per second square. Now, if we simplify it, we obtain that this gravitational field strength must be equals to 1 meter per second square. This will be the unit of the gravitational field strength. Is how we can explain. So hence, the gravitational field strength at a point is equal to the acceleration due to the gravity. We know that at a certain point, this gravitational field strength must be equals to the acceleration due to gravity. As we have tried to see that even their unit are related. If are related, we say that this must be equal at a certain point. So, test mass would be experienced when placed at a point. This is how we look about how this are related. That at a certain point, you can say that this acceleration due to gravity must be equal to the gravitational field strength. As we try to see, the unit is 1 meter per second square. If we simplify from 1 Newton per kilogram, we should obtain that sometimes the unit of the gravitational field strength must be equal to 1 meter per second. Is what we try to observe here. So after there, my dear student, let us go and look about the gravitational potential and the potential energy. This is how we are going to try to see how can we demonstrate the formula of the gravitational potential and also the potential energy. So gravitational potential is represented by symbol Vg. This implies the gravitational potential being represented na symbol yake ambayo tunaita ni Vg. At a point in the gravitational field, its numeral equals to the amount of the work done in bringing a unit mass from infinity to that point. Imagine, my dear student, we have the mass, and that mass is placed at the infinity. So if we want to take to remove that mass from infinity up to the certain point, we should apply this gravitational potential. So gravitational potential, inside the gravitational potential, we are going to look how the work done and also the mass are related. That we have the mass at the point of the infinity. Now we want to take that mass and brought at a certain point. So if we want to remove, it means the work done should be required. The work done should be required because the work done gives us the force times the distance. The force that exert at a certain point to the infinity. The distance and the force that should be implied there. So we require the work done so as to brought the mass that is placed at an infinity point to a certain point. This is how we talk about the gravitational field, the gravitational potential. So on this concept, we should go and look that gravitational potential at a certain point, ambao ni Vg, should be obtained by taking the ratio of the work done, then we divide by the distance. We divide by the mass. Kwa tutaenda kuangalia kwamba how can we obtain the gravitational potential. It means tunaipata kwa kuchukua ile work done, then we divide by we take the work done, then we divide by the mass that is placed at the infinity. But this work done, inside the work done, we should have the force times the distance. But the force that should exert is the gravitational potential. Tutaenda kuiangalia sana sana. So imagine we have a body of mass m, and that body of mass m is placed outside of the S at a point P. Kwamba we have the sphere, and at that sphere at a certain point, it means point P, the mass m is placed at the point P above to that sphere. So at a distance r from the center, therefore that body which is placed at point P cover the distance r as we try to observe here. But suppose that the body is moved from point A. Now we want to move this body from the point A at a distance RA. Kwa tutajaribu kuiondoa pale kutoka kwenye distance from the distance A ambayo tutaita ni radius ni RA ambayo ina imply the distance A to the distance B. It means kwamba from the certain point at a distance RA up to the distance at a point B ambayo tunaita ni RB. But the force of gravity shown in the figure. So the force, what is the force that is required to remove that one? So in order to remove that body from the point A, it means RA, up to the point B which cover the distance RB. Now we should require the force. The force must be required so as to remove from a certain point up to any points. Imagine we have the book, or we have the table at the certain point. Now we want to take that table and remove at that point to a certain place. Now the force should be required. It means kwamba unapokuwa huna nguvu ya kuweza kubeba hiyo meza, it means huwezi ukabeba. Kwa ili uweze kubeba ile meza, it means the force should be required so as to cover the distance that you have been given. So consider the figure 3.39. Now we have our figure here, number 3.39. As we try to observe here. Now, initially the body was placed at the infinity point, the unknown point, ambao tunaita ilikuwa ni kwenye infinity point kama tunavyojaribu. But we tried to remove that body from infinity up to the certain point A, ambao ni kwenye point A kama tunavyoona pale. After keep it that body at the point A, now we should need us to cover some distance. It means from that point A up to the point B as we try to observe. But all of this conducted above to the S as we can to the spherical of the S as we try to see. And this figure try to explain about the gravitational potential at a point as we try to observe here. At the center we have the S. At the center we have the S, and that S contain its own mass. That we can say that this should be the mass of the S. So we observe that, my dear student, we have the distance from this M here, M of the S, up to the point B should be R, should be represented to the distance R, ambayo itakuwa ni sasa na R. So the distance from initially we try to see that we taken our mass from infinity up to the point A, and after attain the point B, A here, we should cover some small distance here, as we try to see this should be the R, about the distance between the point A and also the point B. But from this one up to the point A should be covered as the RA, ambayo itakuwa ni RA kwenye point A, lakini from the center up to the point B should be the distance should be the RB. We should call it as the RB as we try to observe. But the thing that we should consider here is the small distance. As we try to look, the distance that is obtained between between point A and also at the point B. So after observing this figure, what we should go and see here, that is what we are going to try to look here. That, my dear student, the total work done per unit mass when the body is moved from A to B by gravitational force is here. So the work done per unit mass, it means the work done per unit mass that is required to remove the body from the point A to the point B by the gravitational force is given by WAB equals divided by the mass. Why we say that this should be the work done from the point A up to the point B? Because this exactly between the point A and also the point B. The work done that is required to omit this body from point B, from point A up to the point B should be the work done the AB, ambayo tutaita ni work done ya AB. Lakini we have the mass here that we say that work done per unit mass represent the gravitational field strength. So we have the mass. The mass implies that this is the mass of the body from the point A to the yule body ambaye alikuwa wanamchukua sasa wanamsogeza kwenye point B. Yule ndo tunamuita ni mass m, as we try to see here. So the work done along point A up to the point B divided by mass, this should give us the gravitational potential. Hii ndo itatupatia yule gravitational potential. As we have tried to see that if we try to define this work done from point A to point B, should be equal to force times distance. Itakuwa ni sasa na gravitational force times the distance as we try to observe here. But divided by the mass. Kwa badala ya kuandika hii mass, hii work done ya AB tumeweka formula yake ambayo ni gravitational force times the small distance ambayo ina exactly between the point A and also the point B. Now after there we try to introduce the integration. Kwa to introduce the integration from the point A to the point B. It means from RA up to the RB as we try to observe. So substituting FG, we have to record that so we obtain the FG. It means the gravitational force which is equal to the is equal to the universal gravitational constant multiplied by the mass of the S. This should be the mass of the S. It means the mass that is exactly at the center here, as we try to observe. Then we multiply by the mass of the body that we try to shift from point A up to the point B. Then we divide it by R square. This is R square as we try to see the distance from the center there up to the center in point. That means at the point P. So by integrating now, we are supposed to take this one and substitute the place where there is the FG. Kwa tutachukua pale tuta substitute. Ukisha substitute alafu ukaintegrate, it means ukisubstitute huyu mass ataisha hapa juu. Akishaisha tutabakiwa na GMC divided by GMC times that dr divided by R square. Now we should keep GME square. GMC as a constant now and try to integrate the dr over r square. If we integrate, my dear student, we should obtain that VB, it means the gravitational potential must be equal to the negative GME divided 1 over RA minus 1 over RB. This will be the negative, and this represents the equation number 58 on our topic number 3 on the topic of the gravitational simple harmonic motion and also the circular motion. This is our equation number 50 on the third topic. So in calculation of gravitational potential, sasa let us recall using calculation. So in calculation of the gravitational potential, a reference point is always chosen to infinity. The point at infinity is taken to be 0. Kwa tuta consider kuwa ili tuweze kucalculate the gravitational potential, this reference point is always chosen at the infinity. We should choose the reference point at the infinity, and the potential at the infinity is taken to be 0. Kwa hiyo the potential at being taken at the 0 at the gravitational potential. Kwa tuta imagine sasa kwamba RA atakuwa ni sawasawa na 0. It means RA is equal to the infinity, kwa sababu yupo at the infinity. Therefore we should obtain that 1 over RA wa infinity, 1 over RA ambapo RA ni infinity ni sawasawa na 0. Kwa akiwa ni sawasawa na 0, 1 over RA ni sawasawa na 0, we should obtain that this gravitational potential is equal to negative GME divided by RB, lakini RB imply the distance at the distance from the center up to the point P. So this should be the formula of obtaining the gravitational potential. We should consider that the point A is at an infinity. Now if it is an infinity, we should substitute 1 over R ambapo ni infinity, tutapata ni sawasawa na 0, na formula yetu itakuwa ni sawasawa na hii. But therefore the expression for the potential at the given point itakuwa ni hii hapo. Now because if we consider our figure, we should obtain that the RA must be equal to R. Now we should say that gravitational potential must be equal to negative GME divided by R, but negative sign indicate that in the equation signify that the point the object infinity should fall toward the S. The negative sign indicate that the object fall toward the center. It means toward the center of the S. Ndio maana tume imply pale ambao ni negative. Should require the force. Bila force haweza akafall kwenda kwenye center. Kwa hiyo yule negative it means kwamba ni ile force ambayo hata being applied there. So gravitational potential energy. How can we get the gravitational potential energy? My dear student, always the gravitational potential energy should be obtained by taking the work done here, as we try to say that this is equal to the work done in bringing the body from to that point. This should be equals to the work done. Kwa tunaipata ile gravitational potential. It means we obtain the gravitational potential energy by taking GME times the mass. It means kwamba tutamchukua yule gravitational potential alafu tutamzidisha na mass. Ukishamzidisha na mass ambao yule mass of the body, basi tutapata yule gravitational potential energy which is equal to negative GME ambao ME ana represent the mass of the S, but M represent the mass divided by R. That should be the formula of obtaining the gravitational potential energy. So after there, my dear student, hence the gravitational potential energy is a properties of a system of two body masses. So the gravitational potential energy, we should conclude by saying that this is the properties of the system. It means that this appear between the two masses. It means kwamba between the two bodies. It means the mass of the S and also the mass of the body that is placed at a certain point. Kwa kwenye figa yetu tutaobserve kwa kusema kwamba huyu gravitational potential gravitational potential energy ana exert kati ya mass of the earth at the center mpaka kwenye ile point P ambapo ile mass of the body yupo. Kwa ndo tutasema hivyo, lakini M not a single body. Huyo M hawezi akawa ni single body, bali anaweza change akawa ni multiple body. So the negative sign here on our formula indicate that show that the object will have more potential energy as they move away from the earth. Kwa yule negative sign ata indicate kuwa yule potential energy atahitaji it means kwamba yule object atahitaji potential energy kubwa sana kuweza kutoka kwenye kumove from away kumove from the earth to a certain point as we try to see. So by saying that, my dear student, this is the end of our session here. Now I wish you all the best. Have a nice moment.